Oh, okay. If you want to start, I think we can.
Okay, sure. Thank you. So for this week, our lunch and learn is about the OIDC, the introduction. And we already had a lunch and learn about O2, so I'll be just building on top of that. I'll try to avoid repetition if possible. So, so basically, our basic agenda is basically we'll go through the terminologies, the basic terminologies that we had to care about, and some brief history about the authentication, how the OIDC come into picture, and then comparison when possible, and then how we are using OIDC in GitLab. And I also mentioned about non-agenda items, things we won't be covering today. So we won't be covering Auth2, we won't be covering the detailed protocol implementations, and also we won't be covering the OIDC security aspects. We also won't be covering all the OIDC extensions, like all the sessions and other stuff. Also, you won't be covering anything about the verified credentials and anything related to OIDC. So the basic thing is that when we talk about authentication, so this is the Wikipedia definition. The authentication is the act of proving an assertion, such as identity of a computer system user in contract with identification, the act of indicating a person or thing's identity. Authentication is the process of verifying that identity. So that last part is the most important one. It's the verifying a person's identity is the authentication. And we also have the authorization. The authorization is the function of specifying access rights, privileges to resources, which is related to general information security and computer security. And to access control in particular, more formally, to authorize is to define an access. So this is also Wikipedia definition, somewhat complex, but it's the basic things that we have to carry is the defining the access. So there's the difference between authentication and authorization. And the another technical term is the identity provider. I think I don't know how to go to the Wikipedia definition as it is. You can read. So basically, it is the system that provides the identity for the user. And if the identity provider provides the OpenID as the protocol, then we can also call that identity provider as an OpenID provider. So, oh wait, my earpod just fallen down. Okay. So if the identity provider provides the SAML or LDAP, then we can call it as LDAP provider or SAML provider, something like that. And then we have the client. Client is the piece of software that requests tokens from authenticating users. So basically, that's the thing that. So I just read this. So our client is a piece of software that requests tokens either for authenticating a user or for accessing a resource, also often called as a relaying party or RP. A client must be registered with the OP, and clients can be web applications, native mobile and desktop application, etc. So when we have a simple software, for example, if you are just using GitLab and then we are signing in and using whatever we need, then in that case, both the identity provider and client is both. I mean, the relaying party. I mean, we don't have that separation. But when we use the protocol like SAML, OpenID, something like that, then there will be a system which provides the identity. So, for instance, if you are logging with Google or Twitter or whatever social provider that we use, or with Okta, in that case, that will act as identity provider, and then GitLab will act as the client or relaying party or RP. There are several terms that we in the protocols that we use interchangeably, but I think we can use client for now. So before auth, so there was no defined standard for interacting between two services. So for instance, this was how we used to, so if we wanted to integrate or contact, sorry, copy the connection from our Gmail, Outlook, or to LinkedIn. This was the user interface back then. So basically, we'll have to provide the username and also the password in plain text format. And so basically, you can also see a text in below that it says that your contacts are safe with us. We won't be storing passwords or something like that. But it's just that we have to just trust that. And also, even if, for example, if there are some issue with their logging or something like that, and their system got compromised, then in that case also our password will get leaked. So there were no definite standard for interacting things. And then that's how the oath came into picture. And oath basically allowed two systems to, so basically from this thing, in for example, if you are linking now, then it will be like, means there it will redirect to Outlook and then it will ask allow LinkedIn to access this particular data for contact data or something like that. And then you approve it and then coming back to LinkedIn, something like that will be the oath flow. But this was the flow before that. So that was the purpose of oath. And then we'll also go to the concept of delegate authority. So it's the concept of delegate authority allows the owner of a set of resources to delegate access to some of the resources to designated client application without enabling the client applications to impersonate the user. So basically, it allows for instance, I mean, in the example that we just saw, it allows the LinkedIn to get details from Gmail or Outlook or whatever it is without allowing LinkedIn to impersonate that user. We won't be sharing password or anything which is not necessary for that particular operation. And then there's also federated identity. Federation is basically about means if we have account in one user and then using that identity in another service. So SSO is also same thing. Basically, if we have an identity in single system, for example, Okta or something like that, we can use that for several applications. The difference between SSO and federated identity, basically, the SSO is used within an organization. And if it is not specific to an organization, it's called federated identity. So SSO is basically a subset of federated identity. And then even the oath was actually made for authorization to basically, for example, to access a specific resource from another server or something like that. So, but it started being used widely for authentication as well. For instance, for the LinkedIn, I think the Facebook Connect, Google Connect, and for those things, this oath was the authentication thing as well. For example, if let's say to sign in with LinkedIn or sign with Twitter or sign with any of this provider. So basically the oath was the authentication mechanism used as well, even though oath was actually designed for the authorization framework. So we had to use some workaround to use that. And so basically this was the flow for getting authentication with Auth2. So first we will get the access token, and then there will be an endpoint which is the user data, and it can be different for each service. And then we send request to that thing and also using this access token, and then we get the response in JSON or any other format, and then we use that data as the identity of thing. And this was how we used auth as identity mechanism. Sorry, authentication mechanism. We still use that. And then OIDC came into picture. And OIDC actually started early 2004 or something like that. So there were OIDC 1 and 2, which was, they actually started to have identity per user basis. For example, back then when the blogs and all they could actually set up some OpenID Connect. So not OpenID Connect, the OpenID identity for those blogs, and then they can interact each other. But OpenID 1 and 2 did not work out. And then they formed OpenID Foundation, and then they realized that it actually makes better sense if we actually focus on the enterprise kind of author, not just enterprise, the authentication with web. And then that's how the OpenID Connect form. And they did not want to start everything from scratch. And that's why they used the Auth2 as the basis. And then they started the way for authentication with Auth2. So there are mainly two things. One is the endpoints to get the user identity, and also the response schema, how the response should be structured. So for example, in Auth2, it can be like API slash user slash me, or API slash users, current user, or maybe whatever it can be. And also the response can be in JSON, XML, or any format. And also, for example, teacher may be using first name, another may be using first, maybe any capital, another format. I mean, the response and request can be in different format, or OIDC actually make it more structured. And also, it also uses the JSON Web Token, JWT, and then it actually enables to securely represent the data, because JWT built a mechanism for signing the keys, so that when we get the data, we can verify that it's actually coming from the intended source. And basically, the two things, the later protocols are OAuth 2.0 and JSON Web Token. And this is how the JSON Web JWT structure. And basically, it's an encoded form, not encrypted. That's why we need to have some kind of the signature verification mechanism as well. So it will contain three sections. One is the header and payload and the verify signature. And then we will be using, so basically there will be some, I'm not really sure about the name for this one. I think it is claims, I believe. And there will be the default claim like subject, name, and IAT and other stuff. And then there will be things which are added by OpenID Connect. And also, I can also define custom things on top of this one. So this will be how the basic OIDC flow looks like. So when the user clicks on sign in to OIDC, it can be any text. So in our GitLab case, it will be sign in to OIDC. And then when we click on that button, it will redirect to the identity provider. Here it will be the OpenID provider. And then the OpenID provider authenticate the user and then obtain their consent. And there will be a consent mechanism just like auth mechanism. And it will share the profile information with the client application. And then it will redirect back to the client application with the ID token. ID token is a kind of access token, but it will be in JSON Web Token format, so that you will get necessary information from that token. And also we can use there will be a user info endpoint if we need more data. And the benefits of using OIDC over auth is basically about more standardized format and for the endpoint data, and also if implemented properly, we don't have to maintain separate gems for each provider. For instance, we have OmniAuth, Google, Twitter, and all other stuff. But we also have the OmniAuth OpenID Connect, and that gem alone can actually serve several providers, including we can even duplicate the Google provider and any other provider which actually support the OIDC, so that there will be less things to maintain. In OIDC in GitLab, we have three OIDC implementations in GitLab itself. One is the OIDC client. That's what we use for the login with OIDC thing. And we can use that. For example, if you want to use like any generic OpenID provider like Keycloak or any other provider, and in that case we can use this thing. And also we can also configure this for Google and any other provider which support OIDC format. Next thing is OIDC server. The GitLab can act as an OIDC server if the client application want to use the GitLab as identity provider. And for instance, if there is a client application which requires some data from like login with GitLab, they can use this thing. and then I can continue using. And we used Doorkeeper, and Doorkeeper actually implement both. And there is a plugin called Doorkeeper OpenID Connect. I think it was originally written for GitLab, but written as a separate gem instead of including that directly in GitLab code base. And then the third implementation is the CI OIDC provider. Just also an OIDC provider, but used for CI to connect with cloud providers. So I'll just go through them one. So for instance, you can see the screen, right? Hello?
Yeah, it's kind of black right now. I don't know. But
Yeah, I think I mistakenly shared the tab instead of the page. So let me just reshare.
Okay.
Hold on. You can see, right?
Yeah.
Okay. So in the case of CI, so basically the basic issue with one of the issue with CI is that if we want to integrate with any cloud provider like the GCP, AWS, or any other provider, we'll have to create an IAM record, and then we'll also have to securely store the key and secret, and then that we have to store in the CI credential store. And that's not a secure method. One thing is because we'll have to store for long, and then if that got leaked, then that will be a security issue. And especially because the CIE token will have higher permission level, mostly because they will be able to create new, for example, if they are using Terraform or other stuff, then there will be a lot of access level or higher access level for those tokens. And then if it got leaked, then the attacker can make use of that token to do almost anything on the cloud provider. So with OIDC, we can create a short-lived token. Here it will be an identity token, and then here GitLab will act as the identity server. And then the cloud provider, whether it's AWS or any other provider, will act as the OIDC client. And then they will interact with each other and then it will create the identity token, and then there will be some checks like the subject and the issuer to make sure that it's actually by the proper project and other stuff, the basic authorization stuff. And also there will be something like there will be keys as well to sign the request, and then those things it will be verified by this keys endpoint. That's the basic thing for OIDC flow, and this is how it's supposed to set up in the CI. So yeah, this is the OIDC configuration. So in OIDC, there will be a link which is called discovery link. This is optional, not mandatory. But if it is there, then it will be having several data. It will list the issuer data, authorization endpoint. So in auth, we mentioned that there is no standard endpoint for this one. But in OIDC, there are default endpoints, but we can configure. I mean, in applications, we cannot always ensure that it will be on the same endpoint because there can be some restrictions like some V1 or V2 or whatever the application can have. So in that case, they can configure that endpoints in this response, the OpenID configuration response. So here they can use the authorization endpoint should be this endpoint, and token endpoint should be this one. And then this should be the revocation endpoint, this introspection point, and then this is the user info endpoint where we will get the user data. And then this is for JW keys. That's for the keys. And if we got this one, we can see two keys here. So basically, we are using one key for our default authentication, sorry, OpenID provider, and the second key is used for the one for CI. And so it's the standard. WebFinger is the standard for getting the data in this format. That's that OpenID uses to get the data. If we send any emails or any a Mastodon account or anything that support the WebFinger format, we can just enter it here and then it will respond in this format. So you can see this format well known finger. So they are actually following this format for here as well. You can see it's actually starting with well known, I think. Yeah, that's okay. This standpoint. Yeah. So this standpoint for GitLab that we just saw. And there are several things. So, for example, in GitLab, we support these are the claims that we support, and each provider there will be different claims. So here we can see the group claim, group's direct claim. It's about direct membership, and then we have another claim like what are the groups which this particular user has the owner privilege, and maintainer privilege or developer privilege. And we can see all this data. And these things are mostly from OpenID standard. I mean, up to this one, I think. And then this rest of the things, groups is not a standard OIDC claim. This is something that we added on top of it. And then, yeah, and we also support all these scopes. And one thing, so when we are making, even though the structure is kind of similar. If we want to get the ID token, we also have to mention the OpenID scope when we are making the auth2 request, token request. Yeah. Yeah, that's it. I skip many portions either because I don't have enough information and for some I skip because I don't have enough time. But you are feel free to ask any questions.
What are the challenges we face when it comes to the OpenID? How GitLab is using it nowadays? I mean, are there some repeated issues that we face, or something that is being worked on, something challenging when it comes to OIDC and GitLab integration?
Actually, not much actually. So. Especially because we don't have that level of, if we compare with LDAP or SAML, we don't have that level of deep integration with OIDC yet. And for instance, for the groups, for the SaaS users, we don't provide OIDC at all. But for SAML, is already available for SaaS users. And that's one thing. And we don't have the deep support. We recently added groups claim. We also added the group sync for OIDC. But compared to SAML, we don't have that level of integration. So that's one thing. That's the project. That's probably why we don't get that many number of issues. But it's kind of a stable things. But we also get some issues when the OpenID providers don't send the data in a proper format. So for instance, if the provider does not send the email, then we'll try to handle that case, right? So something like that. Because even though we have several attributes that's listed as a standard claims, it's not mandatory to send all of this data because some of the provider may not have email at all. So we'll have to handle those stuff. And also about the uniqueness of these claims. For some projects the email can be unique, some it may not be. It's hard to handle those cases, but other than that, I don't think we are actively having any support tickets for this.
So are we handling this case if if the provider or the client is not sending the email in the while?
That is one of the story that I worked on this milestone.
Oh, okay. Oh, okay. I didn't know about that. All right. Yeah. So currently OIDC is only available for self-managed, is it?
The login part. So there are three aspects, right?
Yes.
The OIDC for CI is available for everyone. OIDC as the OpenID provider is available for everyone. But OIDC as the single sign-on method is only available for self-managed.
Yeah. So GitLab as an OIDC provider is available for everyone.
Yeah, and I think that's the only thing that the GitLab for the federated identity, I think GitLab only has the OIDC for now.
Okay. Oh, okay. Okay.
Because GitLab does not have the SAML providers thing or LDAP provider. Only has OIDC for now.
Okay. Interesting.
Aboobacker, so not necessarily from a customer request perspective, but from implementation gap perspective, do you know offhand 2 or 3 things that we know are key gaps in our implementation on OIDC that we should work on? So for example, that multiple group, that was something we learned in the past couple of milestones. So what are 1 or 2 or 3 things you'd say is we should really tackle outside of general customer requests for features?
Okay, one thing is about the OIDC sessions. We don't handle OIDC sessions at all. So even if the OIDC provider logged out, we don't log out from GitLab. So we don't handle that at all. And the second thing is about the OIDC on group level. Only then we can serve to SaaS customers. And you can also see several things here. So in the specification as well, there is OpenID core, which defines most of the stuff. And then we also have the dynamic registration and then all the logout thing, logout from the GitLab. If you're logging out from GitLab, then it should log out from the provider. And then whether logging out from provider should log out from this thing. And that's the front channel and back channel logout. And I think there are several other stuff that we can potentially implement. And also another thing is the user registration. So when the user comes to GitLab, whether if the user exists or not, we will check whether the user exists or not, and then we also allow them to register, right? But that's something configured per Omniauth provider. We don't allow the OpenID provider or the identity provider to decide whether this particular user should be created or not, right? So it actually add an extra parameter like prompt equal to create. So if it is there, then create the user. Otherwise, just try to authenticate, and then if the user does not exist, then just return that, something like that. There are several areas that we can potentially investigate and see if there are any options to improve. But I think the main thing is about these 2 things, and also we can potentially integrate the scheme for the automatic provisioning of users. We are currently integrated to Scheme and SAML, I believe, and we can probably use the same thing for Scheme and OpenID Connect for the same mechanism, so that the users will get automatically created. And yeah, that's pretty much it.
Cool, thank you.
And this 10 point that we just used, and then we can see these are the claims, and some of them are actually used ID token, which is digital token, and others are implemented in the user and fund point. We have any questions here? No? Okay.
Yeah. Do we have mechanisms of scheme provisioning when the user has been via OIDC protocol connection on OIDC SSO?
I think it's not part of OIDC. It should be separate. I think it's the using scheme with OIDC. I think. Yes, that you have to make sure that it works properly. There's like 2 separate protocols, right?
Yes.
And also, I think what Okta has been working to, for the Okta scheme and SAML works fine together properly, but for the OIDC, I think they are still working on it. I think it's not yet implemented, I believe. I'll have to double check.
This is something the providers will have to work on, right? To give us that sort of mechanism where OIDC can work along with SCIM. Like right now, SIML and SCIM can work together, but I don't know. So this is something that Okta and the other identity providers should open up for the clients, right?
Exactly. And one thing I missed is about the comparison with SAML and OIDC. I think SAML, the protocol has been frozen almost in 2004. There are no active developments. And OIDC is kind of an active framework. It's currently being worked on. And then there are too many areas that they are still working on, including the government's healthcare records and all that stuff. And currently, I mean, for them, they want to replace SAML with the OIDC. That's the plan. So almost anything that will work with SAML should also work with OIDC with the better stat. For instance, the since the OIDC built on top of other protocols like JOT and JSON and O2, I mean, it will be very easier to integrate and also easy to update things in partially. For example, if there are issues with JOT, then that can be handled separately. If there is issue and the JSON endpoint, that can be handled separately, something like that. But for SAML, it's kind of a bundle pack with everything, right?
Yes.
And I think the OpenID Connect is also working for the, working together with the FIDO Alliance for the, sorry. Yeah, to make the passwordless authentication easier. So that means if we want to focus for the future, then we'll have to go with OIDC. We still have to support the SAML for the legacy reasons, but for the future, almost all technologies, I think they are actually trying to bundle OIDC with them, and also even I think some of the identity providers, the recent identity providers, they keep SAML and then just provide the OIDC and other protocols. So this is something that we have to integrate, but not urgent, because for the enterprise customers, they don't tend to adopt new technologies very quickly. So we have enough breathing time, but we'll have to add them anyway.
Okay.
All right. Thank you, Aboobacker. Thanks a lot. We'll post the recording and the link to the slides in our issue. Last call for any more questions. All right. In that case, thank you. Thanks for joining, everyone.
Thank you.